So one more practice problem here. We want to know the maximum area of a right triangle whose hypotenuse is 5. So I've drawn in a little right triangle. I know the hypotenuse is 5. Step 2, I need a formula for that quantity I want to optimize. Here I want to maximize the area, and area is 1/2 base times height. So I have a problem with this formula, which is that it has 2 variables in it. So my job now is to take any other information I have and try to replace one of the variables so that that formula for area becomes a formula in like an equation in one variable, an expression in one variable. So this is what I'm going to do. I know for a right triangle, I can use the Pythagorean theorem to say h squared plus b squared equals 5 squared. So I'm going to write h squared plus b squared equals 25. I'm going to isolate the h. Doesn't matter if I isolate h or b. So I'm going to subtract b squared from both sides and take the square root. So I'm going to have h is say h squared is 25 minus b squared. I can take the square root of both sides. I'm going to get h is the positive or negative version of 25 minus b squared. But notice that h stands for the height of my right triangle, and I can't possibly use a negative height for my right triangle, so I'm only going to keep the plus sign, the positive sign on that square root when I use it in my formula. So I'm going to replace h with the square root of 25 minus b squared. So there you go. Instead of 1/2 base times height, I have 1/2 base times square root of 25 minus b squared. Well, step 3, I did that same thing on the last slide. If I want to maximize a, I'm going to need to find critical points for a, which means I'm going to need to find a prime. So I've found a prime. I use the product rule. So the first is 1/2 b, so it's the first times the derivative. Well, I did it the other way. So this is the derivative of the first, the 1/2, times the second, which I kept it the same, plus the first, the 1/2 b is first, times, and then the derivative of 25 minus b squared. I'm going to have to think of that as 25 minus b squared to the 1/2. So bring the 1/2 down, multiply by 25 minus b squared to the negative 1/2, that's 1 over the square root of, and then the derivative of the inside is this negative 2b. So in the next slide, I've organized that work a little more. Or maybe I didn't. Yeah, I did. Alright, so for critical points, I need to know where a prime is undefined, and that's going to be for any b whose absolute value is greater than or equal to 5, because that would make my denominator either 0 or the square root of a negative number. And I'm going to have to also look for critical points where a prime equals 0. So I took this a prime and I organized it a little bit. So this 1/2 b times 1/2 times negative 2b, I simplified to minus b squared over 2 times square root of 25 minus b squared. The way to solve this equation is to get a common denominator. So I multiplied top and bottom of this first, doesn't seem like a fraction, but I thought of it as a fraction. Multiply top and bottom by square root of 25 minus b squared. So here's this 2 is already in the denominator. I've multiplied by 1 over, or square root of 25 minus b squared over square root of 25 minus b squared, which is why I have that 2 radicals multiply together in the numerator and cancel out their radicals. And I have a square root of 25 minus b squared in the denominator. Now these guys are finally, after all that, these are like fractions. So I'm going to simplify by adding the 2 numerators. So notice I'm going to get 25 minus b squared minus b squared. That simplifies to 25 minus 2b squared. I'm going to need this whole fraction to equal 0, and that'll happen when the numerator equals 0. So I've written an equation setting that numerator equal to 0. I'm going to add 2b squared to both sides. Divide both sides by 2, take the square root. I really would have a plus or minus sign here, but I know that b stands for the length of the base of my right triangle, so I can ignore the negative result. And I get b is the square root of 25 over 2. Alright, so here I am at step 5. I've figured out I only have one critical point. You could think of 5 and negative 5 as critical points, but you can't actually let the base of that triangle be exactly 5, because that would have area 0. So I'm going to make this t-chart. I could put 0 in. I could put 5 in. I could let my base be 5. I want to know what my area is because I want to pick the maximum area. And I got this square root of 25 over 2. I could simplify that. Do I want to simplify that? Take the square root of fraction, take the square root of the numerator and the square root of the denominator. That makes 5 over the square root of 2. So, if I make my area is 1/2 base times height, if I were to make my base 5, then my height would be 0 and the area of my triangle would be 0. So I'm probably not going to choose that one. I want to maximize the area, so if I'm going to try this, what if I made my b 5 over square root of 2? I want to figure out what the height is going to be in that scenario. Or that equation for b that I wrote, the equation for the area that I wrote that only had b's in it, I could substitute this b value in. I think it might be a little bit faster if I just try to figure out what h is going to be in this scenario. So I know 5 over square root of 2 squared plus h squared is going to be 25. It's going to be 25 over 2 plus h squared is 25. I'm going to subtract 25 halves from both sides. I'm going to get h squared is 25 halves. And in this scenario, h as well as b would be 5 over square root of 2. So I'm going to have 1/2 base times height, which is going to be 25 over 4. So this is the maximum area. At the beginning we were asked what is the maximum area of a right triangle whose hypotenuse is 5 centimeters, and that answer is 25/4 square centimeters. We were also asked what dimensions of the triangle produce that area, and that's with the height and the base equaling 5 over square root of 2. The end.